Hi, my name is Marsha binti Muhammad Najib, and I'll do the introduction. Well, what is generator? A regular generator. Well, a generator is a device that converts mechanical energy to electrical energy for use in an external circuit. Generator is basically based on electromagnetic induction. In electrical generation, generator is used as a source of mechanical energy, which include in steam turbine, gas turbine, and also water turbine. This is basically a generator that is being used in a wind turbine. Whenever the flux passing through a circuit changes in EMF is induced in it and a current is generated. The directions of induced current EMF is given by Fleming's right-hand rule or Lenz's law.
Hello, I'm Ren and I'll be presenting principles of nano generators. Here are the pictures of nano devices that can use nano generators to power them up. So the question that I was given was to find a generator which converts mechanical energy into electricity to power a nanoscale device. And the best generator that could do that is a nano generator. So what is a nano generator? A nano generator is something that allows us to harvest or recycle energy from many sources like ultrasonic waves, blood flow, and mechanical vibrations to power nanoscale devices. The nano generators take advantage of the unique coupled piezoelectric and semiconducting properties of zinc oxide nanostructures, which produce small electric charges when they are flexed. So basically the main principle of nano generator is the piezoelectric effect here. So what is a piezoelectric effect? So as I mentioned earlier in the previous slide that the main principle that makes a nano generator work is the piezoelectric effect. So what is this piezoelectric effect? Piezoelectric effect is literally a phenomena which converts the mechanical energy into electricity when passed through a piezoelectric material. So how does this piezoelectric effect work in nano generators? So as I told before, nano generators contain zinc oxide nanowires which are piezoelectric. When energy in the form of ultrasonic waves is passed through the zinc oxide nanowire, electricity is produced in the form of direct current. So by taking the advantage of the fact that the zinc oxide nanowires are piezoelectric, ultrasonic waves can be converted into electricity, making the nano generator the perfect device to be used to power nanoscale devices. For a better explanation, you can read the slide here. So there are two types of piezoelectric effect. One is the direct piezoelectric effect and the second one is the inverse piezoelectric effect. One of the example of piezoelectric device is the sonar, which is used to track fish in the sea. These are the references that I've used. That's all. Thank you.
Hi, my name is Yi, and today I'd like to present about the development of nano generator part 2. I would like to focus mainly on harvesting energy received from the nature to run this nano generator. Can big ocean waves be used to power nano generators? Yes, they can be used. By using blue energy, the energy received from water waves which is produced by the nature. We know that about 71% on Earth's surface is water, and 96% of all those water is from the oceans. But this ocean wave associated energy is huge, but little used towards world energy. This blue energy is capable of meeting all our energy needs. But this blue energy cannot be utilized with traditional power generator due to its low frequency and irregular amplitude. But we can use this blue energy, we can harvest it by the use of these two magnets, a spiral interdigitated electrode triboelectric nanogenerator and a wrapped around electromagnetic generator. So this nano generator is indirectly driven by the non-contact attractive forces between pairs of magnets, and the wrapped around magnet can be easily hybridized. Okay, it produces electricity and either rotation or fluctuation mode to collect energy in ocean tide, currents, and wave energy with its unique structural design. The advantages for using this nano generator, because this nano generator is irreplaceable for harvesting low rotation speed, lower than 100 revolution per minute, or motion frequency lower than 2 Hz. And it fits the frequency range for most of the water wave based blue energy, and the wraparound magnet is able to produce larger output at higher frequency, which is higher than 10 Hz. So such complementary output can be maximized and hybridized for harvesting energy in a broad frequency range. Okay, so apart from this triboelectric electromagnetic hybrid nanogenerator, there are some few hybridized nanogenerator. Okay, there is one category in which the nanogenerators can be used with solar, wind, thermal, everything available sources from Earth. And the other stuffs can be produced from 3D fiber-based organic inorganic materials and chemical solutions. All the hybridized nanogenerator can be used to run LED diodes, light emitting diodes, and the other power sources. Thank you for listening to my presentation.
Why nanomaterial? Triboelectric effect. The triboelectric effect, also known as a triboelectric charging, is a type of contact electrifications in which certain materials become electrically charged after they come into frictional contact with a different material. Rubbing glass with fur or a plastic comb through the hair can build up triboelectricity. The application is triboelectric nanogenerator. There are four fundamental modes for triboelectric generator. Firstly, vertical contact separation mode. Secondly, in-plane sliding mode. Thirdly, single electron mode. Fourthly, freestanding triboelectric layer mode. These are the two earliest modes of mechanical work to produce electrical energy by nano generator. The first one is the sliding method and the second one is the tapping method. Well, for the vertical contact mode, when the two dielectric materials are applied by an external force, the two materials are brought into contact with each other. The surface charge transfer then occurs on these two contacting surfaces due to the triboelectric effect. Electrons are injected from the surface of PMMA into that of captons, resulting in the accumulations of net positive charge on the PMMA side and net negative charge on the capton side. Once there is a relative separation between two materials due to the resilience, EPD is then established between the two electrodes. In this case, EPD equivalent to open circuit voltage between the two electrodes will be induced. Second one is the sliding mode. Sliding mode is basically contact between the nylon and PTFE will result in electron injected from nylon to PTFE. During this period, there is no potential difference between the two electrodes. Once the top plate with the positively charged surface starts to slide outward, relatively displacement in contact mode occurs in the lateral directions. There will be a higher potential on PTFE's electrode than on nylon's electrode. Thus, the electron in the electrode attached to the PTFE film will be driven to the nylon's electrode through the external load. Single electrode mode. When a human finger is brought into contact with PDMS, the charge transfer occurs. Since PDMS is much more triboelectrically negative charge than human skin, it is generating positively triboelectric charge on the human skin and negative ones on the FEP. Electrons are injected from human skin into PDMS. The produced negative triboelectric charges on the PDMS surface is generated between ITO electrode and the grounded reference electrode. The negative charges on the PDMS side will induce positive charges on the ITO electrode. resulting in flow of free electrons via to the external load from the ethol electrode to the ground when the human finger is reverted to approaching the PDMS again, resulting in producing a negative voltage current signal. This is a freestanding triboelectric layer where FEP layer is aligned with the left hand electrode in direct contact due to their different abilities in attracting the electron.